Welcome back, everybody. In the last episode, we learned a little bit about tars and the problems that they can pose for biomass conversion into energy. Today, we're going to learn about one of the solutions to those problems, which are called zeolites. Dave, we've got a zeolite pulled up on the screen here. Can you tell us a little bit more about it?
This zeolite here is called ZSM5. It's one of the most common zeolites they have. Zeolite comes from two Greek words, zeo, which means to boil, and light, which is stone. It gets that name because water absorbed on the surface will come off when you heat it up. They were discovered in the 18th century and used for a wide variety of applications, from kitty litter and detergents all the way to cracking heavy hydrocarbons and biomass pyrolysis, like we use them here in the lab. Now we're going to have some undergraduates tell you a little bit more about how they use zeolites in their research.
Hi everyone, my name is Chris Martino and I am a junior at the University of Connecticut. My goal is to create clean transportation fuels. Here we have some biodiesel, and it has sulfur in it due to how it's made. What we're going to do is take these zeolites and trap the sulfur molecules. This machine behind me is called the GCSCD and is used to detect sulfur compounds present in samples. So this machine is completely automated. First, it selects the sample we designate. The syringe is then washed multiple times before injection. Finally, the sample is plunged by the syringe until 1 microliter is injected into the oven. Next, the needle is washed again. As the needle is being washed, the oven heats up, causing the sample to be vaporized and creates a response on our detector.
Hi, I'm Bianca and I work here at the University of Connecticut. I'm an undergrad and I use zeolites. Now, what I use to test the zeolites is called an FTIR. It's this machine right back here. And what an FTIR does is it creates a spectrum that allows us to see the different chemical bonds that are within the powder. What we do is we load the powder into the cell. And we put it into this machine, which shoots light at it to create the spectrum that I was talking about. Now, when we look at the spectrum, when we change parts of our zeolite, it'll show up differently on the spectrum. And seeing this will allow us to better understand the reactions that are taking place.
Hi, I'm Steve. I'm a chemical engineering undergrad here at UConn. And now that the other members of my group has finished processing the zeolite, they've given it to me, and I've mixed it up with our biomass, which is miscanthus today, put it into the pyroprobe, pyrolyzed it, and from the gas chromatograph and mass spectrometer, we can see how well that zeolite worked at cracking the biomass.
Hello, my name is Shou Cheng. I'm also a PhD candidate student. I'm in the same group with David. I'm sure David has introduced how we utilize woody biomass to convert them into bio-oil. And here what I want to show you is we use a zeolite catalyst during the biomass pyrolysis process. And here you can see how it looks like before the reactions. Well, what I want to also show you is, so after pyrolysis experiment, it becomes black because we have coke and char deposited on the catalyst. And because of coke and char formation, the catalyst is highly deactivated, which means we cannot use this catalyst to do further experiment anymore. So what I'm studying is how this catalyst is deactivated. So you can see this setup. We feed some biomass model compounds, very small molecule compounds, into this setup and doing some catalytic reactions on the zeolite for those compounds. In this way, we can study how the coke and char forms on the catalyst and how they deactivate the catalyst. So I'm going to introduce how this setup works. So you can see here is a saturator. This is where we feed our model compound. and then we purge some flow from the inlet, and the flow will carry the model compound all the way here through the reactor. The reactor is heated with is heated by the furnace to up to 700 degrees Celsius, and we already put a zeolite catalyst in the reactor here, and the reaction will happen inside this reactor. After reaction, the product will go down into this, we call it the liquid collection or condensation system. So we will condense all the hot vapor into liquid here. Then we got our liquid product. So the gas will come through into this, and eventually it goes to a machine called a mass spec, where we can analyze all the gas compositions. While the current research is still going on for investigation of the catalyst deactivation, and I hope you can join our research on this study when you are an engineer in the future.